Yeah, so BYD, the investors reacting to an event last night, BYD hosting, showcasing ultra-fast charging cars, a whole new lineup of models that we based on.
For years, Tesla has been the undisputed leader in the EV revolution, setting the benchmark for battery technology, range, and fast-charging infrastructure. But what if everything we thought we knew about EV dominance was about to change overnight? Well, someone seems to think so. That someone is the CEO of BYD, Tesla's rival. Their new fast charger will destroy the entire EV industry this 2025. This is a breakthrough that could not only challenge Tesla's supremacy, but render its vaunted supercharger network obsolete. So, what can we expect? Let's dive in and find out. The race to faster charging, a critical industry battle. The single greatest roadblock to mass EV adoption isn't range anxiety, battery longevity, or even cost, it's charging speed. While automakers have made remarkable strides in improving energy efficiency and extending vehicle range, no innovation has yet managed to eliminate the fundamental inconvenience of slow charging times. The reality remains that even the most advanced fast charging networks require a minimum of 20 to 30 minutes for a substantial recharge, making EVs fundamentally less convenient than their gasoline-powered counterparts when it comes to refueling. A traditional internal combustion engine vehicle can pull into a gas station, refuel in under 5 minutes, and be back on the road with a full tank capable of delivering hundreds of miles of range. EVs, on the other hand, force drivers to plan their journeys around charging stations, endure extended waiting times, and, in many cases, compete with other vehicles for access to a limited number of high-speed chargers. This does not feel right, especially if you're transitioning from a regular vehicle to an EV. So, how can EV manufacturers make their products more normal? Well, speedy charging is the way to go, and BYD is making this possible. But before we move on to that, let's understand the scale of the problem. You see, the problem with slow charging becomes even more glaring on long road trips, where the cumulative effect of multiple charging stops significantly extends total travel time. Unlike urban environments, where home charging or overnight station stops can mitigate the inconvenience, highway travel presents a logistical challenge. EV drivers are often forced to detour from major routes to locate chargers, wait in line for an available port, and then spend a considerable amount of time replenishing their battery before resuming their journey. This inconvenience is magnified by inconsistent charging speeds across networks, as not all public chargers are capable of delivering ultra-fast charging. Tesla's superchargers, for example, are among the fastest and most reliable, but they are proprietary and not universally compatible with all EVs. Meanwhile, non-Tesla charging networks, such as Electrify America or Ionity, offer varied performance, with some locations suffering from outdated infrastructure, limited availability, or frequent malfunctions. Another major concern is the strain on charging infrastructure as EV adoption scales up. While the current number of fast charging stations may be sufficient for the early wave of EV owners, demand will skyrocket as millions more vehicles transition to electric power. This will inevitably lead to longer queues, more frequent bottlenecks, and increased driver frustration unless charging speeds can be dramatically improved. The problem is further exacerbated by disparities in charging infrastructure development between regions, with urban centers generally faring better than rural or highway locations, where high-speed chargers are often sparse or non-existent. Without a technological breakthrough that enables near instantaneous recharging, mass adoption of EVs could stall, as potential buyers remain hesitant to switch. This is why automakers and battery developers are engaged in a high-stakes race to create the next-generation charging solution: solid-state batteries, extreme fast charging or XFC technology, and new electrolyte formulations are among the innovations being explored to drastically cut charging times. The goal is clear: to make EV charging as effortless and time-efficient as filling up at a gas station. Any company that successfully achieves this breakthrough will not only revolutionize the industry, but also gain an insurmountable competitive edge in the EV market. But don't we already have fast superchargers? Problem solved? No? Well, there is room for improvement, major improvement, and BYD understands that all too well. Current fast charging solutions and their limitations. Despite significant advancements in fast charging technology, no existing solution has been able to completely bridge the gap between EV charging and the near-instant refueling of gasoline vehicles. Even the most advanced charging networks in operation today, such as Tesla's supercharger network, Porsche's 800-volt architecture, and Hyundai's eGMP platform, still struggle with limitations in speed, availability, and infrastructure scalability. While each of these systems represents a major step forward in reducing charging times, they all fall short of eliminating the fundamental inconvenience of waiting for a battery to recharge, particularly in high-traffic scenarios or during long-distance travel. Tesla's supercharger network remains the most advanced and widespread fast-charging infrastructure currently available. Designed specifically to complement Tesla vehicles, these chargers have set industry benchmarks in both reliability and speed. The latest superchargers, particularly the V4 models, are capable of delivering up to 500 kilowatts of power, a remarkable improvement over earlier versions. In ideal conditions, this allows a Tesla vehicle to regain up to 200 miles of range in approximately 15 minutes. However, real-world performance varies significantly based on factors such as battery temperature, state of charge, and charger congestion. While a 15-minute charge sounds promising, it still represents a significant time investment compared to the 5-minute refueling process of a regular vehicle. Additionally, as Tesla opens its supercharger network to non-Tesla EVs, demand for these stations is expected to rise, potentially leading to longer wait times and reduced charging efficiency. Porsche has also attempted to push the boundaries of rapid charging with its 800-volt battery system, which is among the most advanced architectures in the EV industry. This system, used in the Porsche Taycan and Audi e-tron GT, allows for ultra-fast charging speeds that significantly outpace the 400-volt systems found in most other EVs. In ideal conditions, Porsche's 800-volt technology can add roughly 60 miles of range in just 5 minutes and charge from 5% to 80% in approximately 22.5 minutes when using a high-powered 350 kilowatts DC fast charger. However, despite these impressive figures, the system is heavily dependent on the availability of compatible charging stations, which remains sparse compared to Tesla's supercharger network. Even in regions where high-powered 800-volt chargers are available, inconsistent charger performance, limited availability, and occasional compatibility issues reduce the real-world effectiveness of Porsche's solution. Additionally, as with all lithium-ion battery packs, peak charging speeds can only be maintained under optimal conditions, meaning that colder temperatures, battery degradation, and high station usage can all lead to slower charge times than advertised. Hyundai has also stepped forward with its Electric Global Modular Platform, or eGMP, offering 800-volt capabilities similar to Porsche's system. Vehicles such as the Hyundai Ioniq 5, Kia EV6, and Genesis GV60 benefit from this architecture, which allows them to charge from 10% to 80% in just 18 minutes when connected to a 350 kilowatt fast charger. While this is a substantial improvement over older 400-volt charging systems, it still does not solve the core problem of wait times, particularly during long-distance travel. Furthermore, as with Porsche's system, the availability of high-powered chargers is inconsistent, and many charging stations still operate at lower speeds, limiting the practical benefits of the eGMP platform. Even when high-speed chargers are available, bottlenecks at peak travel times and station downtime due to maintenance or technical failures can lead to inconvenient delays. While all of these aforementioned solutions represent the cutting edge of current EV charging technology, they all fall short of truly matching the convenience of gasoline refueling. Each innovation still requires drivers to plan their trips around charging infrastructure, endure wait times that accumulate over long journeys, and contend with the challenges of charger availability and reliability. The race to develop the next breakthrough in charging speed is far from over, and until a true ultra-fast charging solution emerges, EV adoption will continue to be hindered by the fundamental inconvenience of recharging. Making EV charging as fast as gasoline. The ultimate goal for the electric vehicle industry isn't just to expand charging networks, it's to make charging as fast and effortless as refueling a gasoline car. While EV advocates often argue that drivers can adjust their habits by planning their charging sessions around home or workplace chargers, the reality is that most consumers prioritize convenience over adaptation. The widespread adoption of gasoline vehicles wasn't driven by consumers changing their habits to accommodate fuel stations. It was the result of an infrastructure that made refueling quick, ubiquitous, and hassle-free. To achieve mass EV adoption, the industry must meet this same standard, offering ultra-fast charging speeds that remove range anxiety. Only this way can EV brands eliminate any hesitation about switching to electric. Currently, most EV fast chargers, including Tesla's superchargers, require 20 to 30 minutes for a substantial charge, which is still a significant inconvenience compared to a 5-minute gas station stop. While home charging works well for many, it's not a viable solution for apartment dwellers, road trippers, or those without access to private parking. Public charging remains the weak link, and expanding charging networks alone doesn't fully solve the problem. Without significant improvements in charging speed, more stations simply mean more places for consumers to experience wait times, congestion, and reliability issues. The real solution is making EV charging so fast that consumers don't have to change their habits at all, bringing charging times down to under 5 minutes. This challenge has proven so difficult that even legacy automakers like Ford and General Motors have admitted defeat in trying to develop their own superior charging solutions. Their decision to integrate into Tesla's supercharger network, rather than investing in a competing alternative, was a clear acknowledgement that they lacked the technology or infrastructure to provide a better option. By adopting Tesla's North American charging standard, these automakers essentially handed Tesla control over the charging experience for their EV customers, rather than attempting to build their own fast-charging ecosystem. While this move may benefit EV drivers in the short term by increasing access to a more reliable network, it also consolidates Tesla's influence over EV infrastructure. Meanwhile, other major charging networks, such as Electrify America in the US and Ionity in Europe, continue to struggle with reliability and customer satisfaction. Electrify America, which was originally funded by Volkswagen as part of its Dieselgate settlement, has faced persistent issues with broken chargers, inconsistent power output, and frequent software failures. EV drivers report encountering non-functioning chargers far too often, leading to frustrating delays and even forcing them to seek alternative stations. Similarly, Ionity, the European fast charging network backed by major automakers like BMW, Volkswagen, and Mercedes-Benz, has faced criticism for its expensive pricing model and lack of widespread availability. Both networks highlight a fundamental issue. The industry has yet to perfect the reliability and user experience of public charging on a large scale. Until EV charging becomes as fast and predictable as filling a gas tank, consumers will continue to hesitate in making the switch. The automaker or technology provider that cracks the code on ultra-fast, universally accessible, and highly reliable charging will not only remove the biggest barrier to EV adoption, but will also establish itself as the dominant force in the future of transportation. The race is on to see who will achieve this breakthrough first. BYD's breakthrough and what it means for the EV market. BYD has been making waves in the EV industry for years, but its latest innovation, a 1,000-kilowatt ultra-fast charging system, could fundamentally change the competitive landscape. This development marks one of the most significant technological advancements in EV infrastructure to date, challenging Tesla's long-held dominance in the charging space. At the heart of this breakthrough is BYD's Super E platform, a next-generation charging ecosystem designed to redefine industry standards. Unlike conventional fast chargers, which currently max out at around 350 kilowatts for most high-end EVs, BYD's new system boasts an unprecedented 1,000 kilowatts output. This means that in just 5 minutes, an EV could add approximately 400 kilometers or 248 miles of range, rendering the traditional concerns about long charging times obsolete. The implications of this are staggering, as it would allow drivers to replenish their battery in the same amount of time or even less than it takes to fill up a gas tank. To achieve this, BYD has developed a 1,000-volt charging architecture combined with a 1,000-ampere current output, resulting in a 10C charging rate, currently the fastest in the industry. A charging rate of 10C means that the battery can be charged at a rate 10 times its own capacity, an innovation that significantly reduces the time required for energy transfer. This is possible due to advances in battery chemistry, thermal management systems, and power electronics, all of which BYD has developed in-house, reinforcing its position as a vertically integrated EV powerhouse. Unlike Tesla, which still sources some of its battery cells from external suppliers such as Panasonic and CATL, BYD produces its own batteries, giving it complete control over every aspect of its charging ecosystem. The company's Blade battery, known for its durability and resistance to thermal runaway, has been upgraded to handle extreme charging speeds without overheating. To support the immense energy transfer required for a 1,000 kilowatts charge, BYD has also introduced a liquid-cooled charging cable and power delivery system, which prevents excessive heat buildup and ensures stable energy flow. Additionally, BYD's dual-gun charging system allows for the simultaneous use of 2 charging cables, further reducing charge times by distributing power more efficiently. This means that if a vehicle is designed to accommodate such a system, it can receive an even greater energy influx without putting excessive strain on a single charging port. For this technology to succeed, it needs widespread infrastructure support, and BYD has already begun rolling out an ambitious charging station expansion plan. The company has announced plans to install over 4,000 megawatt-level charging stations across China, each equipped with its megawatt flash charging terminal system capable of delivering up to 1,360 kilowatts of power. This move aligns with China's broader push toward clean energy and EV adoption, supported by government initiatives that prioritize electrification. Moreover, these charging stations will integrate with China's existing high-speed rail and urban energy grids, ensuring maximum efficiency and availability. Unlike traditional fast-charging networks, which often suffer from power limitations and uneven distribution, BYD's infrastructure will leverage smart energy management systems, dynamically allocating power based on demand. BYD is not just building this charging ecosystem for theoretical applications, it has already developed 2 flagship vehicles that will be the first to benefit from it. The first one is the Han L sedan, which is a luxury electric sedan featuring high-performance motors, state-of-the-art battery technology, and a 0 to 100 km per hour acceleration time of 2.7 seconds, making it one of the fastest EVs on the market. The second entry is the Tang L SUV, which is a premium SUV that delivers both power and efficiency, accelerating from 0 to 100 km per hour in 3.6 seconds while benefiting from the next-generation fast charging system. Both of these models have begun pre-sales in China, with plans for international expansion in the near future. BYD's ultra-fast charging innovation is now a direct challenge to Tesla's supercharger network, which has long been the industry standard for fast and reliable EV charging. Tesla's latest V4 superchargers currently deliver up to 350 kilowatts, a fraction of what BYD's system is capable of. While Tesla has hinted at future 500 kilowatt superchargers, even those would fall significantly short of BYD's claimed 1,000 kilowatt capability. So, will BYD dominate the future of EVs? Well, it is starting to look like that. Tesla's North American charging standard has been widely adopted by automakers like Ford, General Motors, and Rivian, meaning these companies are aligning their future EVs with Tesla's ecosystem. However, if BYD's 1,000 kilowatt chargers become the new industry benchmark, Western automakers may find themselves lagging behind, unable to compete with the sheer speed and efficiency of China's next-gen charging infrastructure. While BYD's technology is launching in China first, its long-term ambitions are global. The company has been aggressively expanding into Europe, South America, and Southeast Asia. However, scaling such an advanced charging network outside of China presents challenges. For starters, Many power grids, especially in North America and Europe, are not designed to handle 1,000 kilowatt charging stations at scale. Significant upgrades to energy distribution networks will be required. Moreover, Western countries may impose trade restrictions or safety regulations that slow down the adoption of BYD's technology, particularly given geopolitical tensions between China and the US. Also, while BYD's vertically integrated approach allows for cost control, installing thousands of high-power charging stations will require substantial investment and cooperation with local energy providers. Elon Musk has acknowledged the growing threat from Chinese automakers, stating in a recent earnings call that if trade barriers were removed, Chinese car companies would demolish most Western automakers. Tesla has already begun investing in next-gen battery technology, solid-state batteries, and new energy storage solutions, but whether it can match BYD's charging speed remains to be seen. Tesla's potential responses to BYD's ultra-fast charging advancements could involve a multifaceted strategy to maintain its competitive edge. One approach would be a significant investment in ultra-fast charging technology, expanding the supercharger network, and upgrading to a higher voltage architecture could be another crucial step, allowing Tesla to offer even faster charging speeds while maintaining the seamless user experience that has defined its charging ecosystem. Strengthening Tesla Energy might also play a key role, with deeper integration between vehicle charging, home energy storage, and grid-based solutions, positioning Tesla as more than just an automaker, but a dominant force in energy distribution. Additionally, given the growing concerns about China's dominance in EV technology, Tesla may advocate for trade protections that could slow the influx of BYD's ultra-fast charging systems into Western markets, buying time for Tesla and legacy automakers to develop their own competing technologies. But you see, the battle for EV dominance is no longer just about making better electric cars, it's about controlling the entire energy and charging ecosystem. With BYD making aggressive moves and Elon Musk acknowledging the threat, the next few years could determine who truly leads the future of electric mobility. For now, BYD appears to be in the lead. Plus, Tesla is dealing with a perfect storm of its own. Can Tesla survive long enough to compete? Tesla's ability to continue investing in groundbreaking technologies, from advanced EVs to faster charging stations, is now in serious doubt. Once valued at an astonishing $1.54 trillion in December 2024, Tesla's market capitalization had plunged to approximately $7 billion by March 2025. A jaw-dropping $763 billion were wiped out in mere months. This nearly 50% decline wasn't due to a single event, but rather a perfect storm of falling global sales, intensifying competition, and growing public backlash against CEO Elon Musk's increasingly polarizing political stances. The situation reached a boiling point in March 2025, when Tesla suffered its worst single-day stock collapse in years, shedding over 15% of its value and erasing $127 billion in just hours. What many now recognize as a full-scale crisis had been years in the making, and it is now poised to threaten not just Tesla's future, but Musk's entire empire. At the heart of this turmoil lies Musk's decision to align himself with Donald Trump during the 2024 US presidential campaign. While Tesla had long been synonymous with sustainability and innovation, values embraced by a largely liberal customer base, Musk's endorsement of Trump sent shockwaves through Tesla's key markets, including California, New York, and Washington. Studies soon revealed that repeat Tesla purchases in these regions had dropped by 7%, as disillusioned customers distanced themselves from what they saw as a betrayal of the company's progressive ideals. The situation escalated further when Musk made a substantial financial contribution to Trump's re-election campaign. But Musk was just getting started. Following Trump's victory, Musk accepted a position in the administration as head of the newly formed Department of Government Efficiency, or DOGE, an agency that quickly became a focal point of national controversy. Under Musk's leadership, DOGE enacted sweeping cost-cutting measures, privatizing the US Postal Service, slashing budgets for regulatory agencies, and restructuring the Department of Defense in ways that led to thousands of job losses. Agencies such as USAID and the Consumer Financial Protection Bureau found themselves on the chopping block, sparking intense legal battles. At the same time, Musk's continued involvement in Tesla and SpaceX while running DOGE raised ethical concerns, as watchdog groups noted that government agencies that had previously scrutinized Tesla's labor and safety practices suddenly faced deep budget cuts. Critics accused Musk of using DOGE as a tool to dismantle regulatory oversight, allowing his companies to operate with near-total impunity. A federal judge later ruled that Musk's appointment might have violated constitutional law. Meanwhile, consumer resentment toward Tesla was growing, culminating in the Tesla Takedown campaign, which urged customers to divest from Tesla products. The movement gained rapid traction on social media and fueled nationwide protests. The movement's momentum was further amplified when Trump's escalating trade war with China, Canada, and the European Union led to retaliatory tariffs that disproportionately affected Tesla. In Canada, officials proposed a 25% tariff on Tesla imports, with some advocating for an even steeper 100% tax to counter Trump's aggressive trade policies. Europe also turned against the company, with Tesla registrations in key regions plummeting by 63% in France, 44% in Sweden, and 38% in Norway. What followed was a full-blown financial catastrophe. Tesla's stock, which had been attempting a modest recovery post-election, entered a nosedive, shedding nearly 30% of its value in a matter of weeks. The fallout extended beyond Wall Street, as Tesla's first quarter delivery numbers for 2025 fell short of expectations, dipping over 4%, even as EV sales experienced an overall increase in the USA. Adding to the sense of impending doom, several high-ranking Tesla executives began liquidating their shares, selling off over $100 million in stock, while Musk was pleading with his employees and investors to hold on to their stocks. To make matters worse, the company found itself the target of violent, politically charged attacks, including acts of arson, vandalism, and sabotage. Even in Canada, Tesla owners reported a surge in targeted attacks, including keying incidents, tire slashings, and broken windshields. In response, Musk attempted to rally investors and reassure customers, condemning the violence as acts of cowardice and insisting that Tesla's long-term vision remained strong. However, these reassurances did little to stem the panic. Meanwhile, President Trump sought to shield his high-profile ally, denouncing the attacks on Tesla as domestic terrorism and promising to prosecute those responsible. In a bid to boost Tesla's fortunes, Trump even floated new federal incentives for Tesla buyers and staged a promotional event outside the White House, displaying a Tesla vehicle as a symbol of American innovation. Conservative media outlets, particularly Fox News, quickly took up the cause, urging Republican consumers to purchase Teslas to support Musk. But things are not as simple as that. You see, Tesla has been long associated with progressive ideals and environmental consciousness. The company now finds itself attempting to woo a demographic traditionally skeptical of electric vehicles. At the same time, its former liberal supporters had largely abandoned the brand, unwilling to reconcile Tesla's legacy of sustainability with Musk's deepening ties to Trump. With Musk's polarizing presence at the center of its troubles, Tesla must navigate an increasingly hostile landscape where competition is fiercer than ever, regulatory scrutiny is mounting, and its once loyal customer base is rapidly disappearing. Whether it can weather the storm or if this marks the beginning of its decline remains to be seen. What is certain, however, is that Tesla is no longer simply fighting for dominance in the electric vehicle industry, it is fighting for survival itself. This means that BYD can take the lead. BYD's recipe for taking over the EV industry. BYD is the most vertically integrated EV company in the world. Unlike traditional automakers that rely on third-party suppliers for batteries, chips, and motors, BYD manufactures nearly every component of its vehicles in-house, giving it a unique level of control over cost and innovation. This independence has allowed BYD to rapidly deploy new battery technologies, such as its Blade battery, which uses lithium iron phosphate, or LFP chemistry, for improved safety, longevity, and efficiency. Unlike traditional lithium-ion batteries, which are prone to overheating and require extensive cooling systems, the Blade battery is designed to be more resistant to thermal runaway, reducing fire risks. Additionally, its unique cell-to-pack design increases energy density while lowering overall production costs. The result? More affordable EVs for the mass market. The competition among battery innovators is fierce, and the impact extends far beyond just vehicle performance. Advances in ultra-fast charging and battery longevity will dictate infrastructure development, influence government policy, and determine which automakers remain competitive in the years to come. While Tesla, Ford, and GM continue to refine their battery technology, China's battery giants, BYD in particular, are already deploying solutions that could make current fast-charging systems obsolete. The next phase of the EV revolution will not be won by range alone. It will be determined by which company can create the fastest, safest, and most cost-effective charging experience. BYD has already carved out a unique position in the EV industry, establishing itself as the most vertically integrated automaker in the world. Unlike Tesla and other Western manufacturers that rely heavily on third-party suppliers for key components, BYD controls nearly every aspect of its production process, from battery cells and semiconductor chips to electric motors and even the mining of raw materials. This level of self-sufficiency is unprecedented in the industry, giving BYD a critical advantage in cost, efficiency, and innovation speed. While Tesla remains the most recognizable EV brand globally, it still sources batteries from external companies like CATL, LG Energy Solution, and Panasonic. BYD, on the other hand, produces its own batteries, ensuring that its supply chain remains stable and immune to market fluctuations and geopolitical tensions. This autonomy allows BYD to rapidly develop and deploy new battery technologies without the bottlenecks that hinder many of its competitors. Tesla's recent financial downturn has created a strategic opening for BYD to solidify its dominance in the global EV market. In 2024, BYD reported an annual revenue of $107 billion, surpassing Tesla's $97.7 billion, and achieved a 34% increase in net profit to $5.56 billion. The company sold a total of 4.27 million new energy vehicles that year, including 1.76 million battery electric vehicles and 2.48 million plug-in hybrid electric vehicles. BYD's aggressive expansion plans include doubling overseas sales to over 800,000 cars and targeting total sales between 5 to 6 million vehicles. With Tesla's market valuation halving and its brand facing challenges, BYD is well positioned to capture increased market share through technological innovation, strategic partnerships, and a diversified product lineup that appeals to a broad range of consumers. Tesla's loss is BYD's win. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.